Some sequences contain a special product known as a factorial. If n is a positive integer, n factorial is defined as, the notation for factorials is n with an exclamation point, is equal to 1 times 2 times 3 times 4 times dot 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 times n minus 1 times n. In other words, a factorial, whatever that value of n may be, means we take every integer from 1 up to n and we multiply all of them together. As a special case, 0 factorial is defined as 0, again with the exclamation point, 0 factorial is equal to 1. So 0 factorial is equal to 1. 1 factorial is also equal to 1. 2 factorial, well, that would mean we take 1 and multiply by 2. Notice we start with 1 and we multiply by each integer until we get to our number. 1 times 2 is equal to 2. 3 factorial would be 1 times 2 times 3. 3 factorial, 1 times 2 times 3, that simplifies into 6. 4 factorial would be 1 times 2 times 3 times 4. 1 times 2 times 3 times 4, well, that gives me 24. 5 factorial would be 1 times 2 times 3 times 4 times 5, and that gives me 120. Hopefully you are beginning to see the pattern and how we represent factorials. Again, whatever your value of n is, we take every single integer from 1 up to that number and we multiply them. 10 factorial, for example, would be 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. Hopefully you guys all agree that 2 factorial could also be expressed as 2 times 1. Notice that multiplication is commutative. It doesn't matter what order that we do these in. So I can also start with my number n and subtract 1 from each term and multiply. 2 minus 1 gives me 1. I multiply them together. Similarly, 3 factorial could be expressed as 3 times 2 times 1. 4 factorial could be expressed as 4 times 3 times 2 times 1. 5 factorial could be expressed as 5 times 4 times 3 times 2 times 1. So again, we could start with whatever our value of n is and subtract an integer until we get down to 1 and multiply all of those terms together. So one thing to make note of is that it is often more useful to write out factorials by decreasing integers like we have seen here, especially when simplifying factorial expressions. You'll see a couple examples of this coming up. First, let's look at a sequence that involves a factorial. Write the first 4 terms of the sequence. Assume n begins with 0 in this case. We have a subscript n is equal to 3 raised to the nth power plus 1 divided by n factorial. Well, we know how to find terms of a sequence. The first term, because n begins with 0, would be a subscript 0. And to find a subscript 0, all I do is replace all of my n's with a 0. This gives me 3 raised to the 0 plus 1 divided by 0 factorial. Well, 3 raised to the 0, that's 1, plus 1 divided by 0 factorial is 1. 1 plus 1 over 1 leaves me with 2. The next term in the sequence would be a subscript 1. This means I plug in a 1 wherever I see an n in my sequence. 3 raised to the first power plus 1 divided by 1 factorial. Well, 3 raised to the first, that gives me 3 plus 1 divided by 1 factorial. 1 factorial is also equal to 1, leaving me with 4. The next term would be a subscript 2. This means I plug in 2 for n. 3 squared plus 1 divided by 2 factorial. Well, 3 squared is 9. That gives me 9 plus 1 divided by 2 times 1. That's 2 factorial. 2 times 1 is 2, leaving me with 5. And the next term of the sequence would be a subscript 3. This means I plug in 3 for n. 3 cubed plus 1 divided by 3 factorial. 3 cubed, that's 27. 27 plus 1 divided by 3 times 2 times 1. Simplifying out leaves me with 14 over 3. Right, so there we have a sequence that involves a factorial. Let's look at simplifying factorial expressions. Here I have 5 factorial divided by 8 factorial. Now, as I discussed before, it's often helpful to write out your factorial expressions in decreasing orders of integers. In other words, 5 factorial, I could write that as 5 times 4 times 3 times 2 times 1, and 8 factorial, I could write that as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial divided by 8 factorial. Well, why does that help me out, and how can we simplify? Notice all of these products. The products 5 through 1 are all going to divide out, leaving me with 1 over 8 times 7 times 6, which is equal to 1 divided by 336. So simplifying factorial expressions, you're always looking to see what you can cancel out. And again, I recommend writing the factorials in decreasing orders of integers. Start with your highest number first and work downward towards 1. What about when we have something like this? 327 factorial divided by 324 factorial. Now, I certainly don't expect you to sit there and write out all of the terms in this factorial expression, 327 of them. But we can begin to write out a few. Notice that 327 factorial, if we start from the top, would be 327 times 326 times 325 times 324 times 323, and so on. Well, in my denominator, I'm going to have 324 times 323, and so on. What happens? All of those products from 324 downward are all going to cancel out, leaving us with 327 times 326 times 325, which we can then plug into our calculator, giving us 34,645,650. All right, let's look at this one. Now, this doesn't have any particular value, all right? All we know is that n is just going to be some positive integer. We don't know exactly what it is. But we know that factorial means we can start with our largest number and then subtract 1 from each number and multiply all the terms together. In other words, I could write n plus 2 factorial as n plus 2 times n plus 1 times n minus 1 times ... everything down until I multiply finally by 1. Notice all I'm doing here is subtracting 1 from each term. Just as we did when we had the numbers, right? 327 minus 1 gives me the next term. Minus 1 gives me the next term. Well, n plus 2. I subtract 1. Subtracting 1 from n plus 2 gives me n plus 1. Subtracting 1 from n plus 1 gives me n. Subtracting 1 from n gives me n minus 1. We can do the exact same thing in the denominator. Notice we can start with n, and the term we would multiply by next would be n minus 1. N times n minus 1, and the next one would be n minus 2, so on and so forth, until we get down to multiplying by 1. Well, what do we recognize? All of the terms from n all the way down to 1 are going to cancel out from the numerator and the denominator, leaving us with n plus 2 times n plus 1. Let's try one more. 3n plus 1 factorial divided by 3n factorial. Again, the trick is trying to get terms to begin to cancel out. Well, we start with our greatest value. In the numerator, that would be 3n plus 1. The next term would be times 3n times 3n minus 1 all the way down until we get to 1. In the denominator, notice we have a 3n times a 3n minus 1 times ... all the way until we get down to 1. Well, what do we recognize? We don't have to write out all of the terms because we begin to see where they cancel out. Everything from 3n all the way down to 1 will cancel, leaving us with our final answer of 3n plus 1.